Alright, this is number 3 on the projectile motion review paper. So this says a football is thrown towards a receiver at an initial speed of 18 meters per second at an angle of 35 degrees above the horizontal. So the questions are, what's the ball's maximum height? How long will it take the ball to reach the receiver? And where, in relation to the quarterback, should the receiver be if he wants to catch the ball before it hits the ground? Alright, so based on this information, we have to, again, draw our picture, which is what we do first. So we have a football thrown initial speed at an angle above the horizontal. So this is going to be a ground to ground, so it's going to do one of these. So there is the ground. There's our object. We have our 35-degree angle over here, and we have our initial speed of 18 over here. So the questions were maximum height, total time, and where should he be? So the where should he be is basically the delta x, even though it doesn't officially say it. So you have to think about what that means. So we fill out our table. We have x's and y's over here. So the x values are going to include delta x, the initial x, and time in the x direction, where the y values are going to include the delta y, the v initial y, the time in the y direction, which is just time up or time down, and the acceleration in the y. Alright, so as usual, when we try to figure out these types of problems, we want to know the initial x velocity and the initial y velocity because we can't do anything really without them. So in our triangle, again, what we're given is our total, which is our hypotenuse of 18, and we're given our angle of 35. So we need to find the x component and the y component of these two situations. So to find VOX, it's the side that is touching the angle, so that's going to be cosine. So we have VOX is equal to total VO times the cosine of theta, which is going to be 18 times cosine of 35, which is going to end up being a value of 14.74. And then we're going to do our VOY, and that's going to be VO times the sine of theta. So that's going to be 18 times sine of 35. And again, that value becomes 10.32. So we have two speeds now, the x velocity and the y velocity, and those are going to help us to find the information that we're looking for. So what's the maximum height? We need to know how high up the ball is going to go. So there's a couple ways to solve this. So we're going to focus on one of them right now. Alright, so now to find the maximum height, we have a couple of things that we could do. We could find the time, and then we could use that information to find the height. Or what we could do is use another formula to find the maximum height, which we're going to do now, just because we haven't really used that one yet. So this formula is v final y squared is equal to v initial y squared plus 2 gravity times delta y. So what we're looking for is delta y. So v final is going to be the velocity at the peak, which is going to be 0. V initial is going to be the initial velocity in the y direction of 10.32 squared plus 2 times negative 10, and we're looking for delta y. So 10.32 squared is going to end up being 106.5. So we have negative 106.5 equal to negative 20 delta y, which gives us a maximum height after we solve of 5.33 meters. That's solving it that way. Now, if we wanted to find the time way, which we need to find anyway for the next part of the equation, to find time, what we could do is v final y equal to v initial y plus gravity times time. So v final y is 0. V initial y, 10.32, plus gravity, negative 10, and then time. And that time is going to be 10.32 divided by 10, which is 1.032 seconds. And that's going to be the time up, which is the time y. Okay, now if we use the free fall equation, delta y is 1/2 gt squared, that's going to give us 1/2 negative 10 times the time of 1.032 squared, which will result in a 5.33 meter height, which is the same in between these two. So we're going to have both of these. Those are your options for both of the formulas. So both methods are going to yield the appropriate maximum height, which is going to be 5.33 meters. So the next part wants us to find how long it's going to take to reach the receiver, and that time is going to be the total time that it's in the air, which is going to be the time in the x direction. And according to what we know about these types of projectiles, time x is double time y. So we found time y to be 1.032 seconds. So time x is double time y. So that's going to be, time x is going to be 2 times 1.032, which is going to end up being a value of 2.064 seconds. Now that time is going to be the total time it is in the air, and that's going to be the time it takes to reach the receiver. So the final part of the equation wants us to figure out where the receiver should be in relation to the quarterback, and now that we said was the delta x. And we only have one formula for delta x for these types of projectiles, and that's delta x is equal to velocity times time. And that velocity is the x velocity, and that time is the x time. So for this problem, the x velocity that we calculated was 18 cosine of 35, which ended up being 14.75. So we got 14.75 as the x velocity, and the time in the x direction was 2.064. And when we multiply those two together, we are going to get 30.4 meters. So the quarterback and the receiver have to be 30.4 meters apart, and it's going to take about 2 seconds for the ball to hit the ground on that side.